Today we talk about Lambda expressions in Java 8 and above. This is a very important feature introduced in Java 8. It significantly reduces the amount of code you write, and it is almost replacing anonymous inner classes need. Wherever you were using anonymous inner classes, now you can replace all that with Lambda expression. I show you different possibilities by taking a simple example. Let's start by creating a simple thread. You know how to create a new thread. In order to create a new thread, we have to either create a subclass of thread class, and you need to then override run method. That is one possibility. Alternatively, you can create an object of thread class and provide an object that is implementing runnable interface. So let me show you step by step what we use it to do prior to Java 8, what we can do in Java 8. This is mainly to understand Lambda. Once you get good foundation about Lambda expressions and related things, then we'll start fluently using it. So you might be creating a class, something like my code, and that implements runnable. And you know, if you are talking about runnable, you need to implement a run method. So let us say add unimplemented methods. You get it? And I just simply say system.out.println. I say child thread, nothing more. Now to create a new thread, you come here and you say thread t is equal to new thread, and you give an object of my code because the parameter is runnable. For thread, the parameter is runnable. So wherever runnable is expected, I can give my code because my code is implementing runnable. This is what we are doing. So all that you need to do is simply just go run this. You're going to see the method run called, and you will see the message child thread. So here I need to start the thread, of course. Unless you start the thread is not coming into picture. Go run and you get it. Well, this is an old way of doing things. Now, let us do the same thing using Lambda. So, I say thread T2, new thread. We know we need to give an object of a class implementing runnable. And in Java 7 and before, without you creating a class like this, you could have given anonymous inner class. So this is another possibility. You say runnable, and then you are going to define the run method. So this is how you can do it. You are implementing runnable interface and you define the method, that is run, all in one place, and system.out.println, and we say another child. So this is what we are doing, and this is what we are passing to it. So this is how we can create it, and if you format that, you get it like this. Now we are saying create an object of a class that is implementing runnable, and then it is going to define that like this, and here you have this. This is what we need to do. This is called anonymous inner class. What is it? Let me explain. To start with, I'm creating an object of a class that is implementing runnable interface. So somewhere we are creating a class with no name. The name is not there. It's anonymous. But what we know is this class is implementing runnable interface. The class is implementing runnable interface. So we are providing the run method. Here we are providing the run method. So this is the class. It implements runnable interface, defines the run method. Now an object of that class, this new is saying, create an object of this class. Let us say this is X, some unknown name, okay? I want to create an object of this class and that is passed to thread constructor. So a lot of things are taking place here. Number one, it creates a class with unknown name called anonymous class, implements runnable interface because we mentioned it, and then it is defining run method because we defined, and then we create an object of this class because of this new, and the whole object is passed as the parameter to thread class constructor up to Java 7. Creating anonymous inner class was the best possible or the most compact possible option. So we use this a lot in many cases up to Java 7. But then you can see there is a difference between normal class and anonymous inner class. This is all in one. I don't need to create a class like this, give a name and say implements this, all that stuff. Instead, I can make things little more compact. In some cases, it was very much suited and we used it. But now, I'm going to the next level where I say thread T3, new thread, and then I say I want to print another one, and I'm saying lambda child, okay, or maybe lambda expression, whatever. That's all you need to do. Done. And whatever you were doing in the previous cases, the same you are doing in no time. And this is about T2.start, and this is T3. And if you go and run it now, you will see 3 messages. So thread 1 started, thread 2 started, thread 3 also started. T3 is as good as any of them. But if you see, in first case we created an exclusive class for that. In the second case we had to create an anonymous inner class, which was very popular in Java 7 and before. And now in 8, I'm accomplishing the same task using this. So what's really happening? What is that arrow? What is that empty parenthesis? And what are we doing here? Listen carefully. We are talking about runnable interface as a parameter. When I say runnable interface, my primary focus is run method. It is an interface with only one abstract method. Such interfaces are known as functional interfaces. And if you see the signature of run method, it returns nothing and it takes nothing. That's the signature of run method. Now what I'm trying to do is, I'm trying to create a lambda expression, and the lambda expression is basically about this run method. The focus is run method. Because I know runnable interface is what it expects. means it is expecting run method. And I'm providing the code for run method. How? This is about the parameters of your run method. Run method takes no parameters, so we give empty parentheses. Number 2, the symbol is for lambda, the arrow. That indicates we are dealing with the lambda expression. Number 3, this is the body of your run method. So this is what you want to do in run method. And what run method returns? Nothing. Run method returns void. So there is no need for this to return anything. So it is not returning anything, it just displays a message. So what internally happens is, whenever you are using a lambda expression, automatically Java is creating an anonymous inner class for you. And it is implementing the interface that is in question, that is to be implemented here. And it is providing the method. How many abstract methods I have? Only one. That method is defined, and whatever you give as the expression, this goes into it. So Java is creating a class, implementing interface, putting the code you are giving here into run method. So it defines the run method. This is the class created by Java. So it does a lot on your behalf. By creating a class like this, it is eventually creating an object of the class. And that object is what is given to the constructor. So technically, whatever you are doing here is exactly same as what you are doing there. So what you are doing there and what you are doing here, both are exactly same, but your burden is only this. This is all that you need to mention. Creating the class and then implementing interface, defining the method, all that is handled by Java. Even creating the object is done by Java. It just puts whatever code you give here inside the run method. That's it. So it cuts short drastically your job, your efforts, because it is taking so much on its own. It takes so much pain. It does all that, like creating a class, implementing interface, and so on. But this is only possible if you are talking about functional interface, not for every interface. Functional interface is the only candidate for Lambda because it has only one method and your code is related to this run method. So instead of you creating anonymous inner class or a normal class, and then mentioning the interface name, defining the method and providing the body, your job is now cut short to only this. You just give what you want to do. And Java knows what we need there is a functional interface. So it will automatically create a class implementing the interface. It will define that single abstract method and it will put the body there. The job is done. So this is about doing just a small operation. But what if you want to print numbers 1 to 10? You don't want to print just a simple message. You want to take some action. Well, you can. We are just going from lambda expression. This is lambda expression. We are moving from that to lambda block. In case of lambda block, you are going to give a block of statements. So here you are going to give something like braces. And that's where you are going to have the code. So in between those braces you're going to have the code, and this is called lambda block, and you can have any amount of code there. So now I can say for int I is 1 less than or equivalent to 10, I plus plus system dot out dot print ln of I. So this is how you can create a lambda block, and then when you say start, it is going to start and you get numbers 1 to 10. So in place of just a small expression, you can always give a block of code, but whether the block should return a value or not depends on the method. Does method return anything? The run method? No. As run method does not need to return anything, the block need not return anything. But we will see later a few examples where you are expected to return a value, then you must. So this is called a lambda block. A small variation, instead of one statement, you give a block of statements. Now, what you need to do sometimes, the function that you want to execute is already there. So let us say I have something like print numbers. This is already doing what I want. It's printing numbers. Now, one way is to call that function from lambda expression. So let us say this is lambda expression calling a function. So I say T5, and here I just need to call that function, print numbers. And then I say T5 dot start. So this is fine, right? And it works. And let's just comment out this so that we don't get those numbers. Okay. And we can just comment out these start methods, because we have seen them. We don't need to run them anymore. And coming here, now I want to call this method from my lambda expression, and then if I say start, it does that. So there you can see it is doing the same. So this is where a lambda expression is calling an existing method. But when all that you need to do is call an existing method from lambda, then there is a better way to do it. You remove all this and you just give the name of your method. But as it is a static method, you say lambda demo, that is a class name, and you say print numbers. And this is called as a method reference. This is called method reference. You refer to an existing method, and that method is used to get the job done. But don't forget, this is very important, the signature of the method in the interface must be same. What is the method we are interested in? Run method. You see what is expected there? The thread is expecting runnable. So what exactly I need is run, and it takes nothing and returns nothing. Any function that takes nothing and returns nothing can be used using method reference. And you need to give the class name, 2 colons, and then the method name. And this is the new operator in order to refer to a method in a class. This is called method reference. So we discussed about 3 things. How to use lambda expression. This is lambda expression. Then we talked about lambda block. And then we talked about method reference. Instead of method reference, you can call the method through lambda expression. But when All that you need to do is call a method using lambda. Expression is not preferred. Method reference is a better way. So with that, you get some idea about what is lambda. Wherever you are using lambda, Java is internally creating a class, implementing the interface that is needed, defining that single abstract method, and then the body of the method is what you are providing either through the expression or through block or through method reference. That's what exactly Java is doing, and this is very much reducing your burden because you don't have to create a class, you don't need to mention the interface, you do not have to create the method, you just focus on only the code that you want to execute. Now this is our first demo where our focus is on the syntax and we understood different possibilities related to lambda. Now let's get into a slightly different example. Even there I want to use lambda, but we do it for slightly different purpose. So let's call it as lambda demo 2. This time we want to use list of names or list of numbers. You can use anything you like. And if you talk about array, we have something like sort method. And whenever you are using sort method, you also have what is called as, if you go down, you see something like a sort method that is expecting second parameter, which is called comparator. Comparator is an interface. Let us see how we can use this. Now, let's go and work with a small example. I have an array of numbers. Some negative numbers, some positive numbers. These are the numbers. Doesn't matter how many you have. This is an array of some numbers. Now I want to sort it. So when I'm sorting it, this is the way it goes. So what it does, I say arrays dot sort of A. Not the parallel sort, I just want to go for normal sort. And then I can print that for int n colon A and system.out.println n. Now let's go and run this. This is the normal sorting, nothing great about it. It sorts according to the numeric value. Minus 30 comes first and then minus 10 and so on. But I want to sort these numbers not in this way. I want to sort numbers by their absolute value. I want to take the absolute value, means you have to treat minus 10 as 10, minus 30 as 30, and then you have to sort it. Well, to do that, we can make use of the second parameter available for this sort, because the second parameter is called comparator. It is used to compare, and if you go and check what it does, comparator in Java 13, and you can see the comparator is an interface and it is a functional interface. That's a big deal. When you see a functional interface, you know you can apply lambda, because functional interface is having only one abstract method, and this is that single abstract method. That single abstract method is saying, I have compare method which is taking two values and it returns integer. That indicates the relationship between these two values. Let's go in the old way. What do you mean by old way? You can either create a class explicitly or an anonymous inner class. Okay, let's go for a normal class. I say compare numbers, and this is going to implement the interface, and we are talking about comparing, and we say integer, and then we are going to import that. It's coming from java.util. Let's define that, and this is where I want to return the difference between those two after converting them to absolute value. I want to convert them to absolute. And you know, we can use math.abs of O1, and we can say this is something like number 1, number 2, and then I say math.abs of O2, okay, N2, N1. This is what I want to do. And if you see closely, we are doing something very interesting, that's unboxing. Because N1 is of what type? Integer, wrapper class. But math.abs is expecting int, and this is unboxed to int. Whenever a wrapper class's object is converted to primitive type, it is called as unboxing. This is an example for unboxing. Anyway, that's not the theme, but we are eventually converting this to int and trying to return the difference between those two absolute values. And now here I say give an object of what? Compare numbers. You're creating an object of compare numbers and you're giving that. And this is how we do that. Compare numbers implements a comparator, and then we are giving this, well, it expects the type of this and that to be the same. So that's where we are hitting the roadblock. And let me try that. So you can do it in this way, because the array type and what you are trying to use here should be of the same type. The array type is an array of integers, and there also you are talking about comparing integers. And now if you go ahead and try do this, and this is going to be the new result. So you are not sorting by the numeric value, you are sorting by the absolute value. Now the point is we are using comparator, and this comparator is saying it is going to provide compare, and this compare method is used by sort to compare two numbers, and based on what it returns, it is going to then arrange those numbers. Can be done, nothing wrong. Alternatively, one more example might be a little simpler. Names, and we talk about some names, and we are talking about Stephen, then we are talking about Jason, some names. And if I sort these names, in which order are they sorted? Dictionary order. So if I say something like arrays dot sort of names, so for string and colon names, and this is what I want to do. Okay, and it is going to print all the names in the sorted order. That's fine, that's what I want for now. I want everything to be sorted in the order. So you get Bill, then Jason, and then Joe and Stephen. But I want these names to be sorted by the length of the strings, not characters. I want to sort them by the length. So we can do something very similar to this. I say this is compare lengths, and then comparator of a string, and here it is going to give you something like this. Just remove that. Let's create something like this and implement that, and you just need to return something like string 1 and string 2, s1 dot length, we want to find out the length of it, minus s2 dot length. Now that is what I want to provide, and let us see what happens if I give new compare lengths. This is simpler, right? I'm giving compare lengths, and based on what it returns, it is going to arrange the strings. Now save and run. You will see the same data but sorted by the length of the string, not by the characters. So Joe is coming first, then Bill, then the remaining two. So this is an old way of doing things. Still it is possible. It's not that we can't do it. But let us redo the same without all this. I don't disturb this, I leave it. But here, instead of this, let's do it in a new way. What is that? Using Lambda. So what is that interface we are expecting there? Compare. What is the method present? Compare. So I say it is taking two parameters because we need to give parameters there. Then the symbol. Then I say s1 dot length minus s2 dot length. That's all I need to do. There is no need to create any class like that. You just need to give this straight away. Because the parameter is comparator, and I'm giving a lambda expression, and if you see, it is internally creating a class, some class, and what is that? It is implementing comparator. And what is that? It is implementing inside the class compare. And we are saying this is about strings, so it knows that we are passing two strings. And then inside that, it is going to put this expression. Whatever you give, that goes inside this. So Java is creating a class, implementing comparator, defining the compare method, and having two strings as parameters. Why strings? Because that's what this is, a collection of strings. And then it is going to put whatever you give here, and this is supposed to return integer, and that's what it is returning. So instead of you creating an object of a class and create the class, implement interface, define compare method, all that you need to do now, thanks to Lambda, is just the precise expression. And you can make this a little more shorter. But for now, let's run. You get the same result. And you can make it a little shorter by removing string from the parameters. This is possible because Java understands the data type of those parameters. It understands the data type because it knows this is an array of strings. So we don't need to again mention that in parameters. If you want, you can, but even if you don't, there is no danger. It understands. This is called type inference. Type inference means it automatically understands the type of it. Go ahead, run, you get the same result. This is a lot simpler than what we have seen before with the same result. So that's exactly what I've been telling you. Using Lambda is going to simplify what we have been doing, and it's not that you can't do this before. You could do this, but look at the size. This is huge comparatively. This is just one expression. And as we go further and use more and more lambdas, you cannot help but to fall in love with lambdas. That's so awesome. And when you combine these lambdas with the streams, which is again a new feature introduced in Java 8 and slowly being improved in remaining versions. You will see a lot more interesting stuff is creeping in with very little code. That's the beauty. So this is another example where I'm using Lambda expression, and I have a method called compare with the two parameters. So here are those two parameters, and there I'm returning integer. So using Lambda expressions, you avoid implementing interfaces yourself. You avoid creating methods yourself. But one simple requirement is that should be a functional interface, and what you are implementing is the abstract method present in this. So if you see a functional interface, you know you can apply Lambda expression wherever it is needed. So it's just a new possibility without losing any existing functionality. You can still do all that you've been doing, but you can now do the same in a slightly different way. That's the power of Lambda. And this is about a comparator, an interface, and by implementing this we can compare two objects. This is a kind of custom comparison. We are comparing the values ourselves. Do you think sort method is internally calling this when we used it? Yes. When I used sort with an object of compare lens, then this was called many times by the sort method, because that's how sort method can know given two strings which is smaller, which is larger. That's how it can find out. But when you don't give this, then automatically it will sort based on the natural order, means it uses comparative method. You remember there is another interface called comparable. By implementing comparable interface, you can make your objects comparable. So comparable interface with a comparative method is used if you don't explicitly mention this. That's the reason it is going to sort them by the dictionary order. But if you are talking about comparator, then you are going to use your own comparison process. So this is about Lambda. Hope you like Lambda.